This lesson is called Pairs of Lines. In this lesson, we'll talk about parallel lines and perpendicular lines and skew lines. We'll also talk about parallel planes. And then we'll learn about the slopes of parallel and perpendicular lines and how those relate to one another. So what are parallel lines? They're lines that are coplanar and do not intersect, just like railroad tracks or the double yellow line in the middle of the road. You use arrows to indicate that lines are parallel. These red arrows here. That means that the lines are parallel. If you had a second set of parallel lines in the same picture, then it would get a double arrow. The symbol for parallel is this double line like this. And in the figure above, the arrows show that line AB is parallel to line CD. So with symbols, we would write that like this. Line AB is parallel to line CD. We also have perpendicular lines. Perpendicular lines are lines that intersect to form a right angle. Remember, there's 90 degrees in a right angle. The symbol for perpendicular lines is this upside down capital T. That means perpendicular. 4 right angles are formed when you have perpendicular lines. Not just this one, but all 4 of these angles are right angles. And if line M is perpendicular to line N, then we'll use the symbols M is perpendicular to N. That's how we would write that out. Skew lines and parallel planes. 2 lines are skew if they do not intersect and they're not in the same plane, so they're not coplanar. For example, lines CG and line EF. Line CG is in the front here, line EF is in the back. It looks like they overlap in this picture, but if you think of this as being three-dimensional, they do not. So those are skew. Skew lines. They're not parallel and they don't intersect. Now all planes are either parallel or intersecting, and parallel planes are 2 planes that don't intersect. Plane ABC, which is the top of this, and plane EFG, which is the bottom of this, those are parallel planes. So let's do some examples. Name all segments that are parallel to segment AD. Well, here's segment AD, and all segments parallel to that are all of the other ones that are slanted in the same direction. So that's segment BC, segment FG, and segment EH. And when you write these, make sure you write the segment bar on top. What about segments that intersect segment AD? Well, those would be the ones that touch it, and that would be the ones that touch point D, segment DH, and segment DC, and the ones that touch point A, segment AE, and segment AB. So that's segment DH, segment DC, segment AE, and segment AB. What about segments that are skew to segment AD? That means it's not parallel and it doesn't intersect. So really, it's going to be all the ones we haven't mentioned, like segment CG, segment BF, segment FE, and segment GH. None of these are parallel to segment AD, and none of them intersect. So those are the skew segments. When you write the segments, remember to put the bars on top of the letters. And what about a plane that's parallel to plane ABC? Well, plane ABC is the top blue plane. The only plane here that's parallel to that is the bottom one, which is plane FGH. Now let's talk about slope. We've already discussed slope, and the slope of a non-vertical line through the points x1, y1, and x2, y2 has this formula. M equals y2 minus y1 over x2 minus x1. Remembering a few things, that the slope of a vertical line is not defined, and that a slope of a horizontal line is 0. Now when we're talking about slopes of parallel and perpendicular lines, you need to remember these rules. Two lines are parallel if and only if they have equal slopes. So the slopes must be the same when lines are parallel. Two lines are perpendicular if and only if the product of their slopes is -1. And that means you take the reciprocal and change the sign. So a few quick examples here. If you have one line with a slope of 2/3, the slope of the parallel line will be the same. It's also 2/3. And the slope of a perpendicular line, you would flip that and change the sign. So it would be -3/2. Parallel lines have the same slope, and perpendiculars, you take the reciprocal and change the sign. Another example, if one line has a slope of 7, the parallel line has a slope of 7, and the perpendicular line has a slope of -1/7. You flip it and you change the sign. If one line has a slope of -3/4, the parallel line has a slope of -3/4, and the perpendicular line has a slope of +4/3. Flip it and change the sign. So here's some more examples. What's the slope of a line parallel to a line with a slope of 2/7? Well, parallel lines have the same slope, so it's also 2/7. What about a line perpendicular to a line with a slope of -4/3? If it's perpendicular, you need to flip it and change the sign. Flip it and change the sign makes it +3/4. A line parallel to a line with a slope 0, well, parallel lines have the same slope, so that one is 0. A line perpendicular to a line with an undefined slope, well, here's a tricky one, because undefined slope is vertical. What's perpendicular to vertical? Well, that's horizontal, and horizontal slope is 0. So an undefined slope and a 0 slope, those are perpendicular to one another. That's just one of those oddballs that you need to make sure you remember. A line parallel to a line with slope 2, parallel lines have the same slope, so that's also going to be 2. How about these questions? Are the following slopes parallel, perpendicular, or neither? 2/3 and 3/2, well, those are reciprocals, but the sign is the same. So they're not parallel because they're not equal, and they're not perpendicular because the sign didn't change. So this one is neither. 1/3 and 3/9, well, let's reduce this because 3/9 can reduce to 1/3. So 1/3 and 1/3, those are equal slopes. So these are parallel. 1 and -1, it might help if we wrote these as fractions. 1 is 1 over 1, and -1 is -1 over 1. And I can see how I flipped it, even though the numbers are the same, and I changed the sign. So these are perpendicular. 2 and -1/2. I can put 2 over 1 if it helps me see it. 2 over 1 does flip, and the sign changes, so these are perpendicular. Perpendiculars flip it and change the sign. What about 2 and -2? Well, the sign changes, but it didn't flip. Each of these is still over 1. That fraction did not flip. We have no reciprocal. This one is neither. They're not equal, and they're not negative reciprocals. For number 6, 9 and 9, well, those are equal. That's easy. They're parallel. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. Now remember that slope is rise over run. It tells you which way to go up and down and which way to go left and right. If the rise is positive, it goes up. If it's negative, it goes down. If the run is positive, it goes right. And if it's negative, it goes left. Now when you're using the slope as a set of directions and you need to know which way to go, you should really change any integer slopes into fractions. Just put it over 1. And now you can see that you would rise 2 and run 1. That helps if you're plotting the points on a graph. So let's see here. State the directions that these slopes will take you. If the slope is -2 over 3, the rise is -2, so I'm going down 2, and the run is +3, so I'm going right 3. If the slope is 4/5, the rise is 4, that's positive, so it goes up. The run is +5, so it goes right. When the slope is -5, don't forget to put that over a 1. -5 for the rise is down 5. +1 for the run is right 1. And on occasion, you might have the negative be in the denominator. So if it's a +3, this one goes up 3 for the rise. And since the run is negative, this one goes left 8. Rise over run. Now you can write slopes in 2 different ways. If a slope is negative, like this -1/2, you could write it as -1 over +2 or +1 over -2. Because each of these, a negative divided by a positive is negative, and a positive divided by a negative is negative. So these are all equal. Sometimes you might want to write it like this with the negative in the denominator, if you're close to the right side of your graph. And then that way you can move to the left to plot the next point. If it has a positive slope, you can write it as positive, or you can change both signs and make them both negative, because a positive divided by a positive is positive, and a negative divided by a negative is positive. So you have options for both types of slope. So let's practice some of those. If a slope is negative 8/3, we could write that as negative 8 over positive 3, which goes down 8 and right 3. Or we could write it positive 8 over negative 3, which goes up 8 and left 3. Remember, when the run is positive, it goes up. When it's negative, it goes down. When the run is positive, it goes right, and when it's negative, it goes left. When the slope is 2/5, we could write that as positive 2/5. The rise is positive 2, so that's up 2. The run is positive 5, so that's right 5. And when the slope is positive, you can also write it as both of the numbers being negative. So this could also be down 2 and left 5. When the slope is an integer, put it over 1. We could write this as positive 6 over 1, which goes up 6, right 1. Or we could say it's negative 6 over negative 1, which goes down 6 and left 1. And finally, when the slope is negative 1, since it's an integer, we'll put it over 1. We could say it's negative 1 over 1. Negative rise is down 1. Positive run is right 1. And we could also call that positive 1 over negative 1. Positive rise is up 1. Negative run is left 1. So sometimes we do want the denominator to be negative if we start our plotting at the right side of the graph, and that way we can move left instead of going off the edge of the graph. So let's do some graphing. Given this graph, let's graph a line parallel to the given line through point P. So I need to find the slope of this line, and since it's parallel, my slopes will be equal. So let's find some exact points on this line. I see one there and one there, and now let's determine the slope. Let's check the rise and the run. From here to here, I'm going up 4, and I'm going right 3. So if the slope is rise over run, I am rising 4 and running 3. Now the parallel slope is equal to that, which is 4/3. And if I need to, I can also think of that as being negative 4 over negative 3. So now let's graph the other line. From P, remember it has to go through point P, so P is my reference point. I'm going to rise 4, 1, 2, 3, 4, and run 3, 1, 2, 3, and I can put a point there. And I can go backwards. When I go to the left, I'm going to use the negative 4 over negative 3, so I'll rise down 4 and left 3 and go there. And now connect the dots make it as straight as possible. Parallel lines have the same slope, so rise over run to get the slope of the given line, and do that same rise over run for the parallel line. How about this? Same instructions, graphing a parallel line, and it's got to go through point P. So let's find the slope of the given line, find a couple of exact points. There's one, and there's one. And now let's find the slope. Let's rise over run and see what it is. From here to here, I'm rising 1, and I'm running 3. So this is 3 over 1, and it is not 3 over 1. It is 1 over 3. Caught myself there. Rise 1, run 3. And that means the parallel slope is also 1/3. And if I need to think of that otherwise, let's just change both signs there. -1 over -3. And we'll use this parallel slope from point P. If I went with the positive one, rise 1, run 3, that takes me off the graph. So let's use the other one instead. I'll rise down 1, left 3, right there. Let's do it again. Down 1, left 3, down 1, left 3. I got several points, and I can connect those. So rise over run to find the slope of your given line, and make sure your parallel line has that same slope. The instructions change here because we want a perpendicular line. It still has to go through point P, but it needs to be perpendicular. So let's find the slope of the given line. It's rise over run. So let's see what we have. There's an exact point, and there's an exact point. So from here to here, I'm rising down 5, and I'm running 1. Down 5 is -5, run 1, +1 there. So that can reduce to -5 if you want to, but I am going to use this fraction to help me get the perpendicular slope. Because remember, the perpendicular slope, you flip it and you change the sign. Flipping it makes it 1 over 5, and changing the sign, this is negative, so my perpendicular slope will be positive. +1/5. Flip it and change the sign to get perpendicular. And if I need to think of this another way, remember I can make it -1 over -5. And now let's draw. From P, I can go to the right, so I'll use +1/5. Rise 1, run 5. Let's do another one. Rise 1, run 5. And now connect the dots. And I can see right here, there's definitely a right angle going on. And the last two as well. These lines are very obviously parallel. They're never going to intersect. And these lines are parallel. Those won't intersect. So it's good to eyeball the graph and make sure that it's logical. One last one here. Perpendicular line. So I'm going to do the negative reciprocal. And it's through point P. So let's find the slope of the given line. Pick 2 points. I have a point right here, and there's another point here. So I would rise 1, 2, 3, 4, 5, 6, 7, and I'll run 1, 2, 3, 4. So the slope is 7 over 4. The perpendicular slope is the negative reciprocal of that. So this is positive, so this will be negative. 7/4 becomes 4/7. So I can think of this as being -4 over +7 or +4 over -7. This point here, if I'm going to run 7, I can't run 7 to the right. So let's use the one with the negative run. So I'll use 4 over -7. I'll rise 4, and I'll run -7. 1, 2, 3, 4, 5, 6, 7. Right there. Connect the dots. And you can see there's definitely a right angle there, so they are perpendicular. So remember, parallel lines have the same slope. Perpendicular lines are negative reciprocals.